Hi, Professor Zema Ekpete. Welcome all my viewers and my students to another interesting lesson on the Group 2 metals, popularly called the Alkaline Earth metals. Don't forget to subscribe, like, comment, and share this video. I appreciate all of you, all my viewers. I'm thanking you so much. And I thank my students, my subscribers. I appreciate you all. By the end of this lesson, I expect that my students should be able to identify the elements in the group 2 of the periodic table, write their electronic configurations, describe the periodic trends of the group 2 metals, and write the equations of the formation of their oxides, hydroxides, and halides, and also describe some similarities and differences between the alkaline earth and alkali metals. Yes, we are going to look at the elements and their electronic configuration. The group 2 elements will have beryllium with atomic number 4, we have magnesium, atomic number 12, we have calcium, atomic number 20, strontium, with atomic number 38, barium, atomic number 56, and radium with atomic number 88. And as we know, most of the chemistry has been observed only for these first 5 members of the group. We observe that radium is not well established, its chemistry, because it is radioactive. It is a radioactive metal. Why are these metals called alkaline earth metals? It's because of their slight solubility in water. They are not as soluble as the group 1 metals. And why are they called earth? Why is earth added to their name? The earth is added because of their inability to decompose when exposed to heat. And they all have 2 electrons in their valence shell, giving them oxidation state of +2. If we look at beryllium, atomic number 4, its electronic configuration is 1s2, 2s2. Its atomos shell has valence electron 2. We see magnesium, atomic number 12, 1s2, 2s2, 2p6, 3s2. All the elements in this group of metals end their valence electron in the s subshell. That is one of their characteristics. Calcium ended in 4s2, strontium ended in 5s2, barium ended in 6s2, and radium ended in 7s2. I want my students to learn this electronic configuration perfectly well. Their occurrence and extraction. They are shiny and silvery white and reactive metals. They occur in nature in rocks, except radium, that occurs due to the decay of uranium and thorium. Alkaline earth metals occur within compounds in nature, but not in pure form. They cannot be seen in pure form. They occur as compounds. This is because the alkaline earth metals are reactive and will bond with other elements to form compounds. Remember, they have 2 valence electrons that they are willing to give out to form compounds. That industrially produced by electronic reduction of their molten chlorides, as indicated in this equation for calcium. When we have calcium chloride, during electrolysis can be decomposed to calcium and chlorine. We'll get chlorine gas at the end. So it is industrially produced by electrolytic reduction of their molten chlorides. That is how we produce this beryllium, magnesium, calcium, strontium, barium, and radium. What are the uses of group 2 metals and what are their flame colors? Beryllium as a metal is used for aircraft braking systems, in engines, in satellites, and in space telescope. Calcium is the fifth most abundant, and we need calcium for our bones, for use for chalk, limestone, and asphalt. Magnesium also is the eighth. It's used in body metabolism, in bones, in fireworks, and in making cars, plane, and spacecrafts. Strontium is the 15th most abundant. It's very useful for fireworks. It causes a red explosion. Barium has importance in the X-ray of the digestive system, and radium is radioactive, used in cancer treatment. There are colors in the flame. Beryllium will show us white and colorless. Magnesium will have a brilliant red. Calcium a brick red or red and orange. And then strontium crimson and barium apple green. How do we form ions? These metals form ions by the loss of two electrons. For example, we have the formation of magnesium ion here. Magnesium atom, we all know, has an atomic number of 12. The first shell must have 2 electrons, and then the second shell must have 8 electrons, and the third shell, to be completely filled, also should have like 8. But here we have only 2 electrons in the outermost shell of magnesium. And these electrons, magnesium can use it to form bonds. It can donate its electron to especially the elements that are in group 7. They are acceptors. They accept electrons. So when it donates or loses these 2 electrons, it becomes a magnesium ion, just as shown here. The magnesium atom has lost 2 electrons and it has completely lost its third shell, and it has become an ion, similar to what happened with the group 1 metals. Formation of bond. We have here the alkali metals. They react with halogens to form metal halides. We have an example of magnesium reacting with chlorine to form magnesium chloride. In this bond formation we have here, we can see the outermost shell of magnesium without 2 electrons willing to form a bond with chlorine. And chlorine has 7 electrons in its outermost shell, so it needs 1 more electron for it to form the inert pair or form bond, for it to be complete. So it will look for magnesium, but it is not going to just take 1 chlorine. Magnesium has to bond with 2 chlorine for it to donate its 2 electrons, and that is what has happened there. It has donated its electron to chlorine, and it is now able to form magnesium chloride, MgCl2. And then a halide is a compound containing an ionic halogen, and the reactivity increases down the group. The order of reactivity is barium greater than strontium, greater than calcium, greater than magnesium, and greater than beryllium. This is because of the increase in the electropositivity of the elements as we go down the group. Trends across a period and down the group. We find out that electronegativity, ionization energy, electron affinity, atomic radar increases across a period. Non-metallic character also increases across the period, while metallic character decreases across a period. Down the group, we'll find out that electronegativity, ionization energy of these alkaline earth metals decreases down a group. Atomic radar increases down a group. Melting point and boiling point also decreases down the group. Alkaline earth metal reactions. The alkaline earth metals differ from those of the group 1. Their reaction. Radium is radioactive. All the alkaline earth metals react with hydrogen to create metallic hydrides. Calcium plus hydrogen gas react to give calcium hydride. So it applies to all the alkaline earth metals. Beryllium does not react with oxygen, but the other metals react in this manner. Strontium reacting with oxygen to give strontium oxide, magnesium reacting with oxygen to give magnesium oxide, as shown in the equation. Alkaline earth metals react with nitrogen in an extremely high temperature, as shown in that equation. They also react with water. Group 2 metal hydroxides become more soluble in water as you go down the group. The trend can be explained by the decrease in the lattice energy of the hydrous salt and by the increase in the coordination number as shown here. Looking at their coordination number, we'll see beryllium 4, magnesium 6, calcium 6, strontium 8, and barium 8. There is an increase in their coordination number as we go down the group. The larger the lattice energy, the more energy it takes to break the molecules apart into metal and hydroxides. And we find out that beryllium has higher lattice energy compared to the other metals of the group. Because the atomic radii increases the group, it makes sense that the coordination number is also increased, because the larger the metal ion, the more room there is for water molecule to coordinate to it. So beryllium does not react with water. However, magnesium, calcium, strontium, and barium do react to form hydroxides and hydrogen gas, as shown in the equation. Barium reacts with water to form barium hydroxide and hydrogen gas, and calcium reacts with water to form calcium hydroxide and hydrogen gas. There are similarities of group 1 and group 2 metals. The groups 1 and 2 metals are all called S-block elements because their valence electron end in the S subshell. They are both electropositive. These elements are electropositive because they are easily give out their electrons, their valence electron, they easily give it out. And both of them have great chemical reactivity. Both are extracted by electronic method from their salts. They are slippery in untarnished condition. Both react with water to give metal hydroxides and hydrogen, and the hydroxides of both give strong bases with water. So they are very similar, the group 1 and the group 2 metals. What are their differences? The alkaline earth metals are harder, heavier, and have higher melting point than those of the alkaline metals. The alkali metals are the group 1, and the alkaline earth metals are the group 2. The oxides and hydros of alkaline earth metals have more covalent character and are less basic compared to the alkali metals. And then we'll have the calcium, strontium, and barium react less vigorously with water than alkali metals. Beryllium and magnesium can survive in contact with water for a long time. Carbonate and sulfates of alkali earth metals are insoluble in water, whereas those of alkali metals are soluble and undergo what we call hydrolysis, except for lithium carbonate. And then the phosphates of alkali earth metals are insoluble in water, whereas those of alkali metals are soluble, except for lithium phosphate, which is insoluble. Conclusively, we have come to the end of this lecture. The alkaline earth metals have 2 valence electrons and have an oxidation state of +2. They have low ionization energy, low electron affinity, and low electronegativity. They are highly reactive and often form divalent cations, and also know that they are good conductors of electricity. Thank you for listening to this video to this end. We have some study questions for you to attempt. Why are group 1 metals better reducing agents than group 2? List the species in order of increasing size. We have calcium and calcium ion and fluorine and fluoride ion. What types of oxide do calcium, magnesium, and barium form? Why does ionic character increase down the group? Which elements in group 2 make water hard? Why are group 2 metals called alkaline earth metals? Thank you, my viewers and my students. Try and attempt these questions and put the answer at the comment section of this video. Don't forget, my viewers, my students, I appreciate all of you. Don't forget to subscribe, like, comment, and share. Share this video. Make it trend. Always watch it. It will help you as you continue to watch it, and you learn from the classwork, and you will be very good student. Thank you, and see you next class.